Dear NEET aspirants and chemistry lovers, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. The NEET aspirants who are preparing for final NEET exam, which will be conducted on May 3rd, we have very less time, 15 days time only. So in this time, all NEET aspirants must and should be read NCERT textbooks, NCERT exemplar problems, NCERT in-text questions, and NCERT textbook backside problems and all. Most of them, the questions will coming from these textbook only, so that all NEET aspirants must and should be read NCERT textbooks first year and second year thoroughly to get 140 to 150 plus marks in chemistry. Today I am explaining most important questions which are useful for coming NEET exam. The question is, which one of the following statements are true? A. Unlike gallium that has a very high melting point, cesium has a very low melting point. B. On Pauling scale, the electronegativity values of nitrogen and chlorine are not the same. C. Argon, K plus, Cl minus, Ca plus 2 and S minus 2, all isoelectronic species. The correct order of the first ionization enthalpy of sodium, magnesium, aluminum and silicon is silicon is greater than aluminum is greater than magnesium is greater than sodium. Then E. The atomic radius of cesium is greater than that of lithium and rubidium. Choose the correct answer from the options given below. If you observe the first option, unlike gallium that has very high melting point, cesium has very low melting point. Actually, according to NCERT textbook, we have gallium melting point is nearly 29.9 degrees centigrade, that is 302.9 Kelvin, nearly 303 Kelvin temperature, that is low melting point. Even cesium also having melting point 28.5 degrees centigrade, that is nearly 301.5 Kelvin. So that gallium and cesium both are having low melting points. So first option is wrong option. The second option is, on Pauling scale, the electronegativity values of nitrogen and chlorine are not the same. We know very well electronegativity values of that first five elements. Fluorine electronegativity value is 4. Then chlorine. After that oxygen 3.5. Then chlorine and nitrogen both are having the electronegativity values 3. So that chlorine and nitrogen both are having electronegativity same, but they given not the same. So this option also wrong option. The next one is argon having electrons 18 electrons. Then even K plus, Cl minus, Ca plus 2 and S minus 2 all are also having 18 electrons. So that these and all are isoelectronic species. Isoelectronic species. So this is the correct option. Then the correct order of first ionization enthalpy of sodium, magnesium and aluminum silicon. So the valence electron configuration of sodium is 3s1, magnesium 3s2, aluminum 3s2 3p1, silicon 3s2 3p2. Out of these 3s2, to remove electron from this s orbital is very difficult, so that magnesium is more than aluminum. So the correct order of first ionization enthalpy is silicon, then magnesium, then aluminum, then sodium. So D is wrong one. A is wrong, B is wrong, D is wrong. Then atomic radius of cesium is greater than that of lithium and rubidium. Lithium, sodium, potassium, rubidium, cesium. So in groups top to bottom, atomic radius and ionic radius increases, so that cesium has greater atomic radius than lithium and rubidium. So this is the correct representation. So that what are the correct statements? C and E are correct statements, remaining and all wrong. So the correct option is second option. The next question is from practical organic chemistry, that is list 1 and list 2. List 1 they given some ions, list 2 group number in cation analysis. So that we want to find out which group and which cations are present. So here group number in cation analysis, group number in cation analysis is, so here zero group is NH4 plus ion, then group 1 is Pb plus 2, then group 2 is a Cu plus 2. Actually in group 1 along with Pb plus 2, Ag plus 2 and Hg plus 2 also present. Then group 3, Al plus 3 and Fe plus 3. Group 4 is a CO plus 2, Ni plus 2, Mn plus 2 and zinc Zn plus 2. Then group 5, that is barium, strontium and calcium, strontium ion. Group 6, that is group 6 Mg plus 2, magnesium ion. So these are the total groups. So from this, here Al plus 3 is group 3 cation, that is D2. So that D2, the remaining is variation. So this is the correct option. Then C1, what is that? Pb plus 2 group 1, Pb plus 2 group 1. So Pb plus 2 group 1. Then Mg plus 2 group 4, Mg plus 2, sorry, group 6, CO plus 2 group 4. So this is the correct option. Second option is the correct option. So practical organic chemistry and practical inorganic chemistry is most important. Compulsory one question will come for every NEET exam. The next question is, which of the following are paramagnetic? NiCl4 2 minus, NiCO4, NiCN4 2 minus, NiH2O6 2 plus and NiPPH3 thrice 4 times. So that here based on the ligands we want to find out which is a strong field ligands, which is the weak field ligands. Here Cl minus and H2O are weak ligands. So that in these two cases the nickel has plus 2 oxidation state, that is 3D8. The nickel remains as high spin complex in these two compounds, that is NiCl4 2 minus and NiH2O6 2 plus. Due to high spin complexes, NiCl4 2 minus shows tetrahedral geometry, that is sp3 hybridization. So it containing 2 unpaired electrons, that is 3D8 configuration, 1 2 3 4 5 6 7 8. This is 3D. Then 4s and 4p orbitals are available. This is 4s and 4p. These two orbitals are undergo bond formation and hybridization, so that sp3 hybridization is formed, undergo 4s and 4p orbitals, so that this is tetrahedral geometry. In NiH2O6 also nickel shows Ni plus 2, that is 3D8. So here also unpaired electrons are there, 2 unpaired electrons are there, 1 2 3 4 5 6 7 8. So this 3D not involved. Then 4s 4p and 4d orbitals are involved. 4s and 4p 4d orbitals are involved in bond formation. 4s 4p and 4d. So we required 6 ligands. We have 6 ligands. We required 6 orbitals, so that 4s and 4p and 4d orbitals undergo hybridization. It gives sp3d2 hybridization. Due to sp3d2 hybridization, it shows octahedral geometry. Octahedral geometry. So because of octahedral geometry, it shows sp3d2 hybridization even though containing two unpaired electrons. So that NaCl4 2 minus and NaH2O6 2 plus both are having unpaired electrons. So these two are paramagnetic in nature. Unpaired electrons are responsible for paramagnetic behavior. In remaining three options, that is NaCO4 and NaCN4 and PPH3, here CO and Cn and PPH3 all are strong ligands. Strong ligands. So because of strong ligands, pairing of electrons takes place. Pairing of electrons takes place. So these are shows no unpaired electrons are present in that. Here NiCO4 and NiPPH3 thrice, in both cases the D10 configuration is there. Because of strong ligand, both are all electrons are pairing takes place, so that these two undergo diamagnetic character. So these two molecules undergo tetrahedral geometry. Tetrahedral geometry. No unpaired electron is present in between B and E also. So D10 configuration. No, these are diamagnetic in nature. Come to the point of NiCN4 2 minus. Here nickel can exhibit Ni plus 2, that is 3d8 configuration, but Cn is strong ligand. Because of strong ligand, 8 electrons are pairing takes place. So 3d and 4s 4p orbitals undergo hybridization, gives dsp2 hybridization. So that is square planar geometry. Square planar geometry. So that NiCN4 minus is square planar. This is a square planar. No unpaired electron. Pairing takes place because of strong ligand. So out of the options, A and D, these two only paramagnetic in nature. So correct option is third option. My dear NEET aspirants, please subscribe my YouTube channel and click bell icon for daily JEE and NEET updates. Thank you one and all.